number 9, number 9, number 9, number 9.
Okay.
Number 9.
That's, you hear the number. That's where we at.
Number 9.
So, are you ready? We're almost there. 9, 10, 11. 3 more pages. Let's do it. All right. Now we're up to number 49, 7 squared. And that is a circle problem. Okay, so it's all about pi. So what you want to do is, whenever you have circles and you're talking about circumference or area, pi usually slips right in there. And they tell us what pi is. They say use 3.14. So without even doing anything yet, I'm just going to put 3.14 in the pi spot. I'm going to put it in parentheses just so we know we're multiplying it. So we're looking for circumference first. And on the final, they're actually going to give you the formula. So you don't even have to memorize it. But it's good to know. Pi d. Pi d. So I got the pi. And the d, what's the d? The diameter. And the diameter is right there in front of you, 21. That is the diameter. Diameter goes across the circle, through the center. The radius is the one that's halfway from the center to the edge of the circle. This is all the way across, so just put that 21 in here. So this is basically just a calculator problem. So C equals, put it in your calculator, 65.94 cm. That's centimeters. Just straight up, that's it. And then check to make sure that you haven't been asked to round it to anywhere in particular. And it doesn't say round it to anything in particular, so round it to the same, 0.14 were 2 places. That's what the answer is. That's fine. So, good enough. Next. More circles, the same problem, except now we're looking for area. Area is the pi r squared. Pi aren't round. Pi r squared, they say. Again, plug in the 3.14 into the pi spot, because that's what pi is. It's not a variable. It stands for an exact number. Well, not so exact, because it's 3.14. For our purposes, that's plenty exact. But you can get as exact as you want. 3.141590, and you can take it out to a million places if you want. I don't know why you'd want to do that, but some people like to. So it's if you need something incredibly accurate, like some sort of space maneuver, where you're looking at millions of miles, you want to, an extra decimal place could make a big difference. So, but for our purposes, again, 3.14 is fine. And what's R? R is not 21. That's D. So if D is 21, R is just half that. That's from here to here. So that would be half of 21, 10.5. So again, in the R spot, 10.5 squared. Order of op, better do your powers first. And that'll give you 110.25. That's 10.5 squared, or 10.5 times 10.5. And then, next calculator activity is multiply that by 3.14. And you get 346.185. And that's measured in, well, we're still in centimeters. So this is centimeters, but it's area. So it's centimeters squared, or square centimeters, however you want to write that. Because it's like how many little boxes are there, how many little squares. So is that a good final answer? You know what? It's good enough for me. There's no request about where to take it. That's as fine as we can make it. But if you did want to round it, you could do it as 346.19 or 346.2. I wouldn't round it any closer. I wouldn't, unless I asked for the nearest whole number. But you might as well use a little bit of, what do you call that, accurateness, acuity, just so that, because you can, because it's there. A whole number doesn't seem to be the most what we're going for here. But it's up to the problem. It's up to the context. Let's get some more circular stuff. Ooh, number 50. Same deal, same kind of thing. This time they give you the radius. So if you're trying to find the circumference, well, pi is still 3.14. And what's d this time? It ain't 16.5, but if you extend it, then, which is basically just double it, it's 33. 33 in for the d. That's it. And then you go to your trusty calculator, which spits out 103.62 feet. Good enough? It's good enough for me. And what does that mean again? I mean, we just found these numbers. What does this C? So there's our answer. Again, if it's 16.5 from here to here, that means it's 33 all the way across. And then if you wrap that all the way across around the outside, that would go 103 feet. That's what circumference means. Now over underneath there, we have the area, pi r squared, that's being rectangled, the problem a bit, but it's okay, we can handle that. So plug it in, 3.14, and this time the r is given to you, so just go 16.5 squared. Calculate it. Area equals 272.25. That's 16.5 squared. And then you zap it with pi 3.14 for a grand total of 854.865. What is this measured in? Feet squared, or square feet. And what does that mean again? That just means how much room that this fills up in here. I'm going to erase the inside here. It's 16.5 radius, but if it's really that, then there are like a ton of these. If you could make a square foot, I can't really do it with my finger. So you could fit 854, 0.865 square little feet that are little squares that are a foot on each side. You could fit that all inside here. That's what area means. And that's that. Alright. Are we done with circles? For now. Back to the graphs. So we're still flat. We're on the, it's all two-dimensional stuff, flat on the board. Here, the question is, what is the equation of a line that goes through these two given points? Let's go see. I'm going to go put a line through that. So, let's see if I hit it. Yeah, there we go. There we have it. Now my graph's a little bit rough. It's not perfectly equal. But I know how to find that line. And, and let's go back to the that y equals mx plus b. It comes in so handy. We know the slope. You know how we know it? You just count. This is the point 5, -3. That's the point -4, 0. I can count from this point to this point. So I'm going to start from -4, 0, and I always like to do the up or down part. And let's go down. 1, 2, 3. So it's down 3, known as -3, and over 1, 2, 3, 4 to get to the y-axis. 5, 6, 7, 8, 9, and there it is. And I know my slope's negative, even before I start counting and trying to keep track, because it slopes down left to right. It's decreasing. So, and I can reduce that. -1/3. So I'm practically done here. So y equals -1/3 x plus b. And I go to look at my b, which is right around here, but you know what? That's not very accurate. I mean, especially with my drawing, but also, I don't know where that goes through. I'm going to make a guess. It looks like 1 1/3. Actually, it looks less than that, but I kind of know. Since we're having a slope of 1/3, I'll bet the answer is minus 1 1/3. That's what I'm guessing. Am I right? Well, there's only one way to check, and it's to really do it out with the algebra. You ready for this? Of course you are. So we've determined the slope by counting. You could get that by that old subtraction thing where you go minus 3 minus 0, subtract the y's, over 5 minus a negative 4, subtract the x's. Same thing, minus 3 over 9, that becomes a plus, negative 1/3. Okay, so you go y equals negative 1/3 x. We got to find b. How are we going to find b? Plug in one of those points, either one. I'd like to plug in this point because it's easier to plug in, one of them 0. So you put negative 4 in the b spot, x spot, sorry, 0 in the y, and you wind up getting 0 equals negative 1/3 times 4, which is positive 4/3. When you multiply negative 1/3 times negative 4 over 1, you get positive 4/3 plus b. Solve for b, and what do you got to do? Subtract 4/3 from both sides. Holy moly, it's just what I suspected. B equals negative 4/3. So y equals negative 1/3 x minus 4/3. Notice when you find your answer this way, this is the algebra way of doing it. Again, my math lab has another way, that point slope equation. Go for it if you're into it. I'm not going to do it right now because one way is plenty, and I don't usually use that way. So there's your answer by doing it algebraically. You compute the slope, and then you just plug in a point. It would work too if you put in 5, negative 3. You get the same b. And if you notice on the previous page, that's what we had guessed. This was the same. A mixed number actually probably does help in terms of knowing exactly where it's at. All right, one more. There it is. What are you supposed to do? This one's easy. Fill in the table and write it as ordered pairs. So go ahead, plug in 2 for x. What do you get? Y equals minus 2 plus 5. Y equals 3. Great. Let's plug in 5. Y equals negative 5 plus 5. That's 0. Booyah. Plug in 0, which is the easiest thing to plug in. Why? Because that just goes away. Just goes away. So, and you wind up getting plus 5. So, but you have to, it does say write as ordered pairs, so if you're going to follow directions, because I know you'll love following directions, let's write them as order. I'm just making some room here. So the answers are 2, 3. That's one answer. When x is 2, y is 3. And 5, 0. When x is 5, y is 0. And 0, 5. When x is 0, y is 5. These are great numbers because this happens to be the x-int, and that's the y-intercept. Those are really nice points to find, those zeros. There you have it. Another page down, and we're richer for it. Let's go to 10.